In this video, we are going to find vertical and horizontal asymptotes of rational function graphs using their definition. So let's first recall how do we define a vertical and horizontal asymptote. So a vertical line, x is equal to a, is a vertical asymptote for the graph if the limit as x approach a from the left or from the right is equal to infinity or negative infinity. So let's take a look at an example visually of that. So if this was x is equal to a, the vertical line, then an example of that would be as x is approaching a from the left, your graph would shoot up to infinity, so the y's would get bigger and bigger and bigger. And as it is approaching a from the right, your y's would go to negative infinity, get smaller and smaller. And of course, it could also be vice versa. Now, the definition of a horizontal asymptote is that a horizontal line, y is equal to b, is a horizontal asymptote for the graph if now the x's go to infinity or negative infinity and your y's are approaching a number. So visually, what that would look like is if this is a line y is equal to b, as your x's go to infinity, your y's would be approaching b, or if it goes to negative infinity, your y's would be approaching b in this direction. So this would be some visual of what would happen at an asymptote, the behavior. So let's take a look at two rational functions and let's find their asymptote using limits, using their definition. So I'm going to begin by doing the horizontal asymptote. So to find the horizontal asymptote, I'm going to do the limit as x goes to, and I'll start off with positive infinity of f of x. This will be the limit as x goes to infinity of x minus 5 over x squared minus 3x minus 10. Now the key here to find this limit is that when you're looking at the x's that they get extremely large, you look at the leading term of the top and the bottom part of your rational function. Why is that? Well, the reasoning behind that is as your x's get really large, the tail end, so the other terms, don't affect the fraction as much as the leading terms. So think, for example, if I plugged in x equals 10, 10 minus 5, the 5 would have a lot of impact on the 10. But if I plug in a billion minus 5, all of a sudden that minus 5, it doesn't affect it as much anymore. And this is going to continue as the x's get bigger and bigger. So now what I have is I have the limit as x goes to infinity of x over x squared. But that can simplify because they both have an x. And the bottom will have 1 left, so this would be 1 over x. And now what we need to do is we need to use what we call the reciprocal limit rules, which is that the limit as x goes to positive or negative infinity of a number divided by x over p, where p is greater than 0, this limit will go to 0. And the reason for that is because as the bottom is either getting really large, the whole fraction itself is going to 0. Think about it, 1/4, 1/5, 1/10, 1/100. This is going to 0. And it's the same thing if you put a negative in the front, negative 1/4, negative 1/5, negative 1/10. They're still going to 0. So we use that now to take the limit because the limit as x goes to infinity of 1 over x is going to be 0. What this is telling us is that this is our horizontal asymptote. This is the b. So your horizontal asymptote is y is equal to 0. And it's also going to happen, right? It didn't matter here if I also had a negative in the front. If I had the limit as x goes to negative infinity of 1 over x, it would still be 0. So both directions, as x goes to infinity and negative infinity, they're both going to approach 0. Now let's take a look at the vertical asymptotes. So the key about taking the vertical asymptotes is that if you have a vertical asymptote, it will come from the zeros of the denominator. Now the zeros of the denominator of a rational function can only be one or two things. It can either be a whole or a vertical asymptotes. So what we're going to check now is which one they are. So I'm going to take my denominator, which is x squared minus 3x minus 10, and I'm going to set this equal to 0. So I'm going to have x minus 5 times x plus 2 is equal to 0. This gives me x is equal to 5 and x is equal to negative 2. And I'm going to take the limit of both of those. So I'm going to have the limit as x approach 5 of f of x. This is equal to the limit as x approach 5, and now I'm going to plug in what my actual f of x is. So x over minus 5 over x squared minus 3x minus 10. And now I can plug in 5, so I'm going to get 5 minus 5 over 5 squared minus 15 minus 10. And that's going to give me 0 over 0. We call this the indeterminate form. What this is telling us is that whatever factor is making 0 in the bottom is also making it 0 at the top, which means that we can simplify. So what we're going to do next is we're going to simplify our function here. Maybe if I can, here we go. So I'm going to have the limit as x approach 5, and I'm going to write it in factored form now, so x over 5 over x minus 5 times x plus 2. And now these factors cancel, which was the factor that was creating an issue. So I have the limit as x approaches 5 of 1 over x plus 2. And now I try to plug that in again, and I'm going to get 1 over 7, which means that the limit exists, and the limit is 1/7. Visually, what that tells you is that at x is equal to 5 and y is equal to 1/7, you're going to have a hole there. So this will be a hole, not a vertical asymptote. So now we're going to do the same thing, but for -2. So we have the limit as x goes to -2 of f of x, which is equal to the limit as x goes to -2 of x minus 5 over x squared minus 3x minus 10. This is going to give me -2 minus 5 over 4 plus 6 minus 10, which is going to give me -7 over 0. This is not the indeterminate form, which means that whatever is making 0 in the bottom is not making it 0 at the top. And this tells you that it's going to be a vertical asymptote. Now, what you might ask is, well, how do I know whether it's going to infinity or negative infinity and from which side? And that you're going to have to use other aspects of the function. So you could draw a table, or you can actually start to graph it. But for now, all we need to know is we're not asking to graph for whether it's going to infinity or negative infinity. We just want to know where it is. And so by not getting the indeterminate form, we know it's a vertical asymptote. So I have a horizontal asymptote at y equals 0 and a vertical asymptote at -2. Let's do one more problem. Let's move this out of the way. So maybe this would be a good time if you like to try to pause and try it on your own. If not, let's take it away. So I'm going to do the horizontal asymptote first. So I'm going to have the limit as x goes to infinity of f of x. This is going to be the limit as x goes to infinity of 2x squared plus 4x over x squared minus 1. But when I look at infinity, the leading terms is what I want to look at. So this is going to give me the limit as x goes to infinity of 2x squared over x squared. But that simplifies. They both have an x squared. So this is the limit as x goes to infinity of the number 2. Now what this is telling you is no matter what x is, the limit is 2. The number is 2, I should say. So if x is 5, the number is 2. If x is 100, the number is 2. If x is 1,000,000, the number is 2. The number is always 2, so the limit has to be 2. This also is not going to affect it if I was looking at negative x's, because obviously it's always just 2. So in both directions, you have the limit is 2, so you have a horizontal asymptote at y is equal to 2. Now the vertical asymptote, I'm going to have to look at the zeros of the denominator. So I have x squared minus 1 is equal to 0. This is a difference of squares. X minus 1 times x plus 1 is equal to 0, which means that x is equal to 1 and x is equal to -1. I then take the limit of both, so I'll start off with -1 of f of x. So I have the limit. I keep writing the limit until I've actually taken it. So right now I'm just rewriting f of x. So I still have to write my limit symbol. Now I'm plugging in, so I drop my limit symbol. So I'm going to have 2 times a positive 1 plus 4 times a negative 1 over 1 minus 1. This will give me negative 2 over 0. This is not the indeterminate form, so I know that this will be a vertical asymptote. I do the same thing for the limit as x goes to 1 of f of x. This will be the limit as x goes to 1 of 2x squared plus 4x over x squared minus 1. This will give me 2 plus 4 over 1 minus 1, which will give me 6 over 0. Again, this is not the indeterminate form, which means that I have a vertical asymptote. So I have a horizontal asymptote at y equals 2, a vertical asymptote at 1, and a vertical asymptote at negative 1. Make sure you always write asymptotes as equations of lines. If you write an asymptote as a number, it makes absolutely no sense. Asymptotes are not numbers, they are lines. I mean, sometimes they are actually more than lines, they can be any sort of shape. But in this situation, vertical and horizontal asymptotes are equations of lines, so you need to write x equals and y equals.